Viewers waiting. Oh, concurrent viewers. Okay, I'm having 2 viewers. Okay, good. What? Did my stream just start? Okay, it's weird. Okay, so let's look at the sounding again. Very unstable. Wow. Very unstable lapse rates. Yikes. Hail up to... Oh, wow. Weak tornado. Wow. Nice. We actually have a small tornado threat. New York City, probably because of the wind shear. You'll be having winds coming off the water here. Let's see. Let's look here. This is Long Island. This is where you usually have those turbulent weather coming in. I'll be right back. Okay, let's look. Severe. So, good chance of hail. Supercell weak. Non. Level of free convection. So your LCL, your lifted condensation level, and your level of free convection looks pretty good. Lifted condensation. Yeah, so your LFC, so your level of free convection over your level of condensation level. So your level of free convection over your lifted condensation level. So yeah, that's how you calculate the moist adiabat. So your dry adiabats is always cooling at a rate of 9.8 degrees Kelvin per kilometer, or Celsius per kilometer. So 9.8 degrees Celsius per kilometer, while your moist adiabat cools at about, so 9.8 is the dry adiabat. This is the dry. This is your moist adiabats right here. So your moist adiabat is actually cooling slower. So it's actually, so this is your dry adiabat right here. And then boom, it just, the moist adiabat just really is just incredible. Your moist adiabatic lap rates is about 3.3 degrees Fahrenheit for every 1,000 feet. Or basically so it can go between 3.6 and 9.2 degrees Celsius per 1,000 meters. So the slower it cools, so if your dry adiabat is cooling really slowly, then the air is incredibly unstable. Because here's the thing. Your air aloft is pretty cold, by the way, right? Looking at 700 millibars, your surface temperatures are going to be below 10 degrees Celsius. So you could see, yeah, you're going to be having some pretty good convection. Let me explain why. So let's look at the NAM. Let's look at your 700 millibar levels. Let's look at the mid-Atlantic, which is our area. Let's look on Wednesday. So here you have the cold air coming in. So this is warm air aloft, right? 8 degrees Celsius, close to 10 degrees. And then boom, look what happens on Wednesday afternoon. 4 or 5 degrees Celsius. Very, very warm, cold temperatures aloft. And yet your surface temps, look at that, mid-upper 80s. And yet while the air aloft is going to be colder, you'll still be in the 80s. So you're going to have some really strong convection. Boom, storms coming right there. So your lapse rates are going to be very steep that afternoon. Look at that hail. Wow, 3.65 inches. At least one of the models is showing that size of hail. So you're going to have a big hail threat Wednesday afternoon. Incredible. Look at the lapse rates. Jeez. You're gonna have a lot of convection. Of course, today your lapse rates are really like, not very conducive for thunderstorms. That is why we really didn't have anything, actually. Yeah, that really didn't happen. Let's look at tomorrow afternoon. Yeah, it's unstable, but not very. I mean, it is kind of close. You can see it. Also, there's an inversion layer right here. Almost an inversion there. So, see, it's actually cooling. It cools off and then it warms up. So, okay, so yeah, severe weather Wednesday. So yeah, severe weather is definitely likely on Wednesday, especially late in, early in the afternoon. Your biggest chance of severe weather will be early in the afternoon on Wednesday, between 2 and 4 p.m. in New York City. Okay. Where did I put it? I swore just 2 seconds ago. It just vanished. Okay, I'm back. No. I'll be right back. I'm just making myself a bit of a midnight snack. Okay, so let's look at the models. I'm just looking at tomorrow. So it is going to be unstable, but not very. So let's look at mid-level lapse rates for Wednesday. So somewhat conducive to some small hail. I mean, Normally you want to have your low-level lapse rates to be very high and your mid-level lapse rates to also be high. Like this, oh yeah, that's some very high lapse rates. See how steep they are right here? Those are some very steep lapse rates. Yep. And then Wednesday, just boom. Look at that. Look at Wednesday. So this is where I think your greatest severe weather threat will be across southern New Jersey. Please subscribe to my channel. I'm probably just gonna edit it, of course. Discussing wildfires. And Canada, as well as the Metro this week, Wednesday. Please weather, earthquakes, and volcanoes. Boom. Okay, perfect. Should probably be there. Let's look now. Now I think the 9 a.m., the 7 a.m. observation should be out now. Because it's now there 7 a.m. I believe. Because I know it's already way past 7 there. 6:30 a.m. there. No, that is actually, that happened hours ago. So yeah, this is an older observation. See, right now, keep in mind it's probably there already 9 a.m. Al-Waki, Iraq. Okay. Let me look at pivotal weather, because I actually have some log in. I'm going to be logging into pivotal weather. Oh, there we go. European high resolution. So let's be looking at Wednesday afternoon. So this is July 21st. So this is midnight. This is Wednesday afternoon. Thunderstorms coming into New York City area. Right here, boom. So you'll be having a threat of severe weather. Of course, continental United States. National. Regional. It's weird. Normally. Okay, already paid. Okay. Why am I getting? I used to be able to view the. Oh, it's for precip. Okay, 2 meter temperatures. Models. Yeah, Middle East. Look at that. Wow. That is crazy. Isn't that India? No, that's not a monsoonal low. That is crazy. That is a very powerful storm. They're even talking about snow in freaking Kazakhstan, guys. Like, snow. Like, come on. Precip type and rate. Jeez, snow. Look at all that snow there. Yikes. Look at that system. 964, 963. Oh yeah, that's probably, that low is probably just there because of yeah, that's probably your monsoonal low, but I still want to see that. Winds. Incredible. That is just crazy. 96 hours out. Oh yeah, that's probably your monsoonal low. But still, that is just incredible. Precip type rate. Let's look at total QPF. Let's look at 384 hours out. Jesus Christ. Let's look at winter weather. Let's look at total snowfall. Yikes. So, oh my God. You're talking about a really crazy weather here. Look at all that snow. That's literally northern Pakistan, northeastern Afghanistan, parts of Tajikistan. So this is Kyrgyzstan, Tajikistan. So eastern Tajikistan is going to be walloped by snow in the middle of summer. But keep in mind that is very high in elevation, but still, in the middle of summer, they're going to be getting a blizzard. In the middle of summer. Like, this is not normal at all. Like, guys, I don't know if this is normal for them, but keep in mind this is not the Arctic. This is literally at the latitude of New York. This is not happening in the Rockies, but this is happening in Asia. This is probably to do with the monsoon. Like, the ocean is crazy hot, so it's probably pumping more moisture than normal. But this is good. Like, you want to see this in summer especially. That's great news for snowpack. It's great news for next year's rain, like next year's droughts. Because if you're going to be having droughts, you'll still be having a lot of snowpack that will actually add on to the water reservoirs. This is what we need to see in the United States. Crazy snow in the middle of summer. Just incredible. Like, wow. I mean, the world is warming like crazy. We're having record heat all over the place. Like, up the wazoo with record heats. And yet, wow. Just, my mind is blown, just so to speak. Wow. Like, there has to be a reason for this. Probably it's because of your adiabats. So while you're not having cold air aloft, colder than air than normal, you're having adiabatic cooling because of upslope flow. So, you know, as air goes up, it cools and condenses. So, snow, but that is a lot of moisture. Like, that is just crazy. I mean, I don't know. It's probably not going to make the news, but still, wow. Tajikistan, somewhere. I mean, this is looking at Tajikistan, by the way. And eternal cold in highlands. That's probably the highlands. What you're probably looking at is the highlands. because this is a large part of Tajikistan. Like, a large part of Tajikistan is very mountainous, with elevations above 15,000 feet. Keep in mind that K2 or Communism Peak is Communism Peak is found in border of Uzbekistan and Tajikistan, or Communism. It used to be known as Communism Peak. It's in Tajikistan, by the way. So see, it's not called Isomil Somoni Peak. So most of Tajikistan, right here. So see, yeah, Murghab is probably going to be having a lot of snow. Like, you're having a large area. Banzaigun, let's see where that is. That's northeastern tip of Afghanistan. And it's looking in here, but I'm talking about like northernmost Pakistan. What I'm looking at right now is in this area here. Glacier, so a lot of snow. Yeah, so this is a Bradishev. Barshi, no. I doubt it's the models are even gonna. I mean, the area. $78 degrees. Peak Patkor. Gora means mountain. Peak means peak. Gora means mountain. Paymazar. That's where Paymazar. That's very high in elevation. That's like yeah, that's literally in the ice. Like, that's in the glaciers. Sea of Fark. Come on. Yeah. Chikhok. $68, $55, $63. Okay, that's, yeah, it's just crazy. relatively warm-blooded fish. Wow. Nope. Anyway, let's look at the models again. Just crazy, like, wow. I mean, keep in mind that probably it's normal for them to get snow considering how high it is. So this is not because, like, oh, climate change is a hoax. No, climate change is real, and we need to treat it as such. Like, those lows that you're seeing, that is actually monsoonal. This is a monsoonal low. See right here, very low pressure. Like, that is an... This is the lows at what brings India its rains. These are monsoonal rains, by the way. Total QPF, let's look at, go all the way to hour 384. So Mumbai, yeah, gets a lot of rain, literally about a global drought. Yeah, Asia is very wet right now. Like, that is, okay. This is good. Like, you want to be in the plus. Plus is good, minus is bad. So, most of the United States, why is there a green here? Oh, yeah, rainfall departure from normal. A lot of rain, a lot of rain, a lot of rain. So the only, yeah, looks like we're a little dry actually here in the Northeast. We're a little bit below normal. Of course, China is probably having a lot of rain right now. Yeah. 2 dams in Inner Mongolia, and guess where Inner Mongolia is? Right here. What does blotted out means? Desert. Blotted out white means desert. So your Saharan desert. So this is all desert areas. Of course, Europe has been having crazy rainfall, especially Ukraine and Germany. This is where you've been having all this flooding. Xi'an rain. Wow, Xi'an has been... So India, looking at India, of course, very wet. You want to see that. Like, you definitely want to see a lot of water here, especially in Pakistan, in the desert areas. You want to see rainfall. Look at that. Southern Israel is considered a desert. Yeah, desert, 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 desert. Surprisingly, I believe white means desert. I could be mistaken. Yep. Oh yeah, I remember the East Coast drought. And then of course the drought reversed itself a year later. So we got 2001 East Coast drought. Okay, now let's look at tau right now, because also I look at volcanoes. I would really appreciate if someone could comment on my videos. I'm gonna guess about between 10 and 20 earthquakes. 36, not bad. 20 low frequency? Huh. 3 hybrid events. Yesterday you didn't have a lot of low frequency and you didn't have any hybrid events. So something is changing with tau. nothing too crazy. ASP. Uh-huh. Portal. To.ov ingv.it/web data signale _rt dot asp equals loc equals pozzoli pozz question mark and ID map. Okay, everything matches so far. Question mark. Wait, map STA. Ah, darn it. There we go. Now I fixed it. Okay. Now we can look at the okay. Let's look at very quiet actually. Like literally nothing. It's just dead quiet. A little tremor here, a little tremor there, but like hardly noticeable. Ooh, nice little swarm today. Okay. Whoa, 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 whoa. Look at that. Boom, 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 boom right there. Yeah. Good little popper swarm there. Still subsiding. Still subsiding. Normal. No evidence of any uplift. Look at that. Yellowstone has been subsiding consistently. Subsidence. This is where, if there's any uplift, it would be here, because this is the direction hotspot's moving. Subsidence. Orange means caldera, so orange means caldera outline. See? Caldera boundary. See? Caldera boundary. Long Valley has always been kind of slowly uplifting. Like a very slow and steady uplift. In the last 3 years, you went from what, 5 centimeters of uplift? Like, it's really slow. You literally only had, what, 10 centimeters of uplift? And it's very slow. Like, really slow. Again, slow, very slow uplift. Not concerning at all here, but This is where you should be looking for uplift. So August, where we are now. So keep in mind, right around 0. This is, and then 2 years later, you're having, 2 centimeters of uplift. Like, come on, really slow. There is uplift occurring, but it's really, really slow. Little quakes, little pop, 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 pop quakes. Little, ooh, that's interesting. Drumbeat quakes. That is something very interesting. That's actually almost a drumbeat pattern that you usually see at volcanoes, like Mount St. Helens. Interesting. So this is outside of the caldera boundary, but still a little bit of uplift. So the entire area is basically slowly uplifting here. Not related to volcanoes here, so this is outside of caldera boundaries. Mono Lake volcanic field. Probably, yeah. Again, uplift. The whole area is slowly uplifting here. Again, uplift here. Wow. Okay, that is some pretty strong uplift. Now that is some strong uplift right there. That is about, in just a few months, that is about 2 to 3 centimeters of uplift. And largely on the eastern side of the caldera. Right here, boom, yep. So let's see here, yep. Where does the uplift mostly occur? I've noticed the strongest uplift was in this area here. From 0 to greater than 2. It's about 2 centimeters of uplift in only what? Few months, like less than a month. I mean, it's very small, but that is a pretty fast uplift. But then you want to look at different areas. But look, doesn't look like there's any correlation here. But then you want to look at here, uplift, a little bit of uplift. So you definitely want to put more seismometers in this area here. Wait a second. You do see this, right? How there's no mountains here, and then look. Almost a circular feature. Look, possibly another caldera. Caldera. You know, this could also be just some features, but you do want to investigate the fact that this could actually be one large caldera. especially because of how some of these mountains are shaped. This could be faultal. This could just be fault scarps or just mountains forming. But you also could entertain the fact that this could be a caldera. But maybe it's not, because you're not seeing any other rounded structures. This is probably the only volcano in the area. Tilt meters. Oh, come on, kidding me? LVO, Long Valley Observatory. That's literally LBT. Yeah, this is considered a very high threat volcano. Not even a high threat. A very high threat volcano. You see that red there? So moderate. Most of your very high threat volcanoes are either in Alaska, along the Aleutian Trench, or along the Cascadia subduction zone. But then you find one very high threat volcano that is not in that area. Oh, look at that, Yellowstone. High threat. Yeah, it's not very high, just high. Very low. There's actually a moderate threat volcano in Alaska. Look at that. Okay, let's look at Long Valley Caldera. Let's look at the very high threat volcanoes. Long Valley. Caldera is considered very high threat. Aviation score of 129. Mauna Loa. Kilauea. Wow, that's actually a very high aviation score, 48. Yellowstone Caldera has a very high aviation, 27. The highest aviation score is, of course, Mount St. Helens. I don't know why Kilauea has such a high. Oh, yeah, because of its explosive eruptions. St. Michael Island. Yes, now we can look at the weather again. I'm about to be going to bed, so now it's... Let's look at Wednesday afternoon. Ooh, whoa, no freaking way. Oh my God. Look at those DBZ values. Oh my God, 70. Oh my God. Freaking crap. Oh my God. Freaking supercells. Oh my God. Oh God. Oh my God. That is going to be a freaking enhanced. That has to be a freaking enhanced, guys. Enhanced. Not even a slight. That is an enhanced risk day, guys. That is crazy. That is freaking supercells, guys. Oh my God. Updraft Helicity swaths. Let's check it. Like, if that's got to be like near 200. Damn. Boom. Right in New York City. Yeah. Wow. Oh my God. Woo. That is a freaking crazy day. Like, Jesus Christ. Oh my God. Over 200. Yeah, that is going to be a freaking enhanced. That's got to be enhanced at least. Not a moderate, but an enhanced. God darn. Jesus Christ. That's probably got to be some tornadoes there. Like, let's look at the winds. What's going to cause that? Okay, you'll be having cold front coming through. Right here. There's your cold front coming in. Right along the cold front. Boom. Hailers are going to be developing. Oh my God. Like, I just, like, laughed. Like, that is crazy. That is just insane. Jesus Christ. That is just going to be a crazy afternoon. Like, I mean, I don't know if that's going to happen, but damn, that is just out of this world. Simulated reflectivity. Okay. Okay, you understand that. You have convection in the morning, right? And then boom, just nailing right into New York City. Like just, yeah, I am not gonna issue a marginal for that day. Heck no. Maybe like I would issue an enhanced for wind and hail. Maybe I'll give a 2% for tornadoes, and I would issue a 30% for wind and a 15% for hail. That's what I would do for Wednesday. That's what I would do. And not in this whole area. I would issue the core in here. This is where I would put the enhanced. Based on this run. Okay, let me go back. So here's where I would put the enhanced. So I would put a slight for the New York City. Yeah. It's already thunderstorms around noon. So if these storms don't develop, I don't know. Here I would issue a marginal for Massachusetts. Marginal. Yeah, marginal here. And I would put most of Connecticut in a slight risk. I would put actually a slight, because these could be severe storms. Any of this convection could become severe. So I'll put slight, marginal here, slight, and then enhanced. And anywhere from like the central New Jersey up to New York City, southern Connecticut, into that enhanced. So yeah, they're indicating supercells, embedded supercells in that convection. So yeah, definitely a threat of severe weather. Wow, just wow. You know what? I'm gonna do another stream, and I'm gonna be talking about the severe weather now.